What's up guys, welcome to this video. So today I will share a data structure called tree. I believe tree is not very unfamiliar to you guys. The tree is a connected structure with no cycles. That's a good definition given by the graph theory. Usually it is a non-linear hierarchy structure with single root. So let's see what is it. So this is a graph of a binary tree. And usually we'll call the node at the top the root. So in this graph that we can see that A is the root of the tree, and the definition of the root, to be more formal, is the node with no incoming edges. So you can see that node A only has outgoing edges. And also, so what is the edge? The edge is the line or relation between two nodes. This is called edges. So if node A could go to node B, we call it A is the parent of B. And in other words, B is the child of A. In this graph, not only B, but C, D, E, F, G are all children of A. And the opposite to the root, we also have another terminology called leaf. So leaf basically means a node with no outgoing edges. So in this graph, we have 4 leaves, which is the node at the bottom, D, E, F, G. They are called leaves of a node, of a tree. So leaf basically is node with no outgoing edges. Since A is the parent of B and B is parent of D, so A is the sister of D and D is the descendant of A. And also we have another relationship which is called siblings. So in this graph, B and C are siblings. D and E are also siblings. So siblings basically means they share the same parent. So we also have some more definition of a tree. Usually you will see many problems like find the height or depth of a tree. So what's the definition of a depth of the tree? So depth basically means the length of root or path from root to the leaf. So in this graph, we have the depth will be A, B, D, the length of path A to B to D, which is 3. And we also have some questions like find the minimum depth or maximum depth of a tree. So what is the definition of maximum depth of a tree? Usually we call it the height of a tree. So in other words, height of a tree is the longest path from root to the leaf. Okay, so if we given n nodes, what is the max depth and what is the minimum depth of it? So just like this graph, so if we were given n nodes, the max depth which will be n, because we can have like one child each node, so we have like n children, so we have n nodes. So what is the minimum depth of a tree? So that's a very interesting math problem. So let's do some math improvement of how we find the minimum depth of a tree given n nodes. So suppose we have a tree like this. So this is a binary tree. So each node could have 2 children. So we have 3 different levels. We can give like level 0, level 1, and level 2. Okay, so in total we have 7 nodes. The height of this is, I mean, it's 3, right? So it's like 2 levels plus 1. So by each level, how many nodes we can have at most? So each level, I might say it is 2 power of level. Am I right? So we have some math formulas right now. So we have like 1 plus 2 plus 4 plus 8 blah 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 plus the last one plus until level, right, equals n. So we have some math formula. So basically it is the first item here. So math formula is first item here times 1 minus 2, how many in total? Level divided by y minus 2 equals n. So this is minus 1, right? So we have just like switch them. Equals n. N plus 1 equals 2 over level. Okay, we take log on both sides. Basically log n equals 2 level. Okay, so we found a formula. Level is log n. So what's look like in the programming world? So this is, we can see this is a definition, like a pseudocode of a node, and it has 3 different parts. Like I may say 2 different parts. The first, it is called information. So each node must carry some information. Otherwise, why do we need it, right? Why do we need a node? So node itself has some information. This could be any type. It could be string, could be char, it could be boolean. It could be a very complicated, maybe a hash, something. It doesn't really matter. And also it has the child node, basically. So we'll know that, okay, what's the position of this node in this graph is. Which node does it connect it to? So in this one, there's a binary tree. So we have 2 nodes, which is left and right. You can call it A and B, it doesn't matter. Okay. A tree, it is a recursive structure. So this is a recursive structure. So what does it mean? Its children always have the same exact structure as its parent. Here, 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 here. They all have the same structure. Okay. So let's give an example. Okay. So in B, so we'll notice like node B is look like something like node the data equals B, left equals D, node D, and right equals node E. Okay, so we also want to introduce another concept which is called empty node. We also will notice in Python it is called none, and maybe in Ruby it's called nil. In JavaScript it's called none. This is called empty node, and empty node is the smallest node you can ever have. Okay, so you may be curious, okay, what does a leaf node look like in this structure? Any leaf node will have will look like something like this node. So first thing is the data equals maybe, for example, D, and the left is none, and the right is also none. So this is something we store the leaf node. Okay. So today I briefly introduce the concept, the terminology of a tree structure. Welcome, leave any comments under this video, and in the next video I will go through some legal questions, some easy ones and some harder ones in the next video. Thank you for watching, and if you like, subscribe and click like. See you guys in the next video.